Now here the question is, we are given this limit x tends to 0, sin x minus 10x whole square minus 1 minus cos 2x to the power 4 plus x to the power 5, 7, tan inverse x to the power 7 plus sin inverse x to the power 6 plus 3 sin to the power 5x. Now here we'll take 10x common, so we can write this as limit x tends to 0, 10x whole square, and then will be cos x minus 1 whole square, and we can write this as 2 sin square x whole to the power 4 plus x to the power 5 upon 7 tan inverse x to the power 7 plus sin inverse x to the power 6 plus 3 sin to the power 5x. Now what we'll do is, we'll divide everything with x to the power 5. So we can write this as limit x tends to 0. Now it will be this 10x whole square upon x, and we'll write this as 1 minus cos x upon x square whole square, and here will be 2 to the power 4 sin to the power 8x upon x to the power 5 plus 1. This is 7 tan inverse x to the power 7 upon x to the power 5 plus sin inverse 6 upon x to the power 5 plus 3 sin to the power 5x upon x to the power 5. Now here this is 1 by 2 square, 10x upon x is 1, and then we have this additional 10x which will be 0. So this part is 0. Here also sin to the power 8x upon x to the power 5 will be 0. Tan inverse x to the power 7 upon x to the power 5 will be 0. Sin inverse x to the power 6 upon x to the power 5 will be 0. And sin x upon x to the power 5, it is 1. So answer to this limit will be simply 1 by 3, and that's your option C. Now here the question is, we need to find this limit x tends to 0, tan inverse x tends to 0, tan fraction part of x minus 1 into sin fraction part of x upon fraction part of x and fraction part of x minus 1. Now we'll write it left hand limit. It will be limit x tends to 0 negative tan fractional part of x minus 1 into sin fraction part of x divided by fraction part of x and then fraction part of x minus 1. Now we'll let x as 0 minus h, and we know that fractional part of minus h is 1 minus h. So we'll write this as limit h tends to 0 positive. Now tan of fraction part of minus h minus 1. So there will be 10 minus h. And here it will be sin 1 minus h. Here also it will be 1 minus h, and here it will be this minus h. Now tan h upon h, it is 1, and this value will be sin 1. So left hand limit here is sin 1. Now we'll come to its right hand limit. Now for a right hand limit, we'll take limit x tends to 0 positive tan fraction part of x minus 1 into sin fraction part of x divided by fraction part of x into fraction part of x minus 1. Now we'll let x as 0 plus h. Now in this case it will be this limit h tends to 0 positive, and we know that fraction part of h is simply h. So it will be this 10 h minus 1 into sin h upon h into h minus 1. Now sin h upon h, it is 1. So here this value will be tan 1. Now left hand limit is sin 1, right hand limit is tan 1. So this limit is non-existent, and that's your option D. Now here the question is, we need to find this limit x tends to 0 cos ax to the power cosec square bx. Now we put this limit cos 0 is 1 and cosec 0 is infinite, so it is 1 to the power infinite form. And for this form we have the shortcut that we can write it as e to the power limit x tends to 0. Now this is cosec square bx and it will be cos ax minus 1. Now we'll write this as limit x tends to 0 minus, and then we'll write this as 1 minus cos ax into 1 upon sin square bx. Now we'll multiply and divide it with a square x square, and here we'll multiply and divide it with b square x square. Now this is standard limit, which is 1 by 2, and this is standard limit, which is 1, and x square will cancel. So answer to this limit will be e to the power minus a square upon 2b square, and that's your option C. Now here the question is, we are given this function fx, which is defined in terms of fraction part function. Now first we will find its limit x tends to 0 positive. So this is 10 square fractional x upon x square minus greatest integral function of x whole square. Now we know that x is greatest integral function of x plus fraction part of x. Now we square it, we can write x square minus greatest integral function of x square, and that will be fraction part of x square plus 2 times fraction part of x into greatest integral function of x. So we write this as limit x tends to 0 positive 10 square fraction part of x upon fraction part of x square plus 2 times fraction part of x into greatest integral function of x. Now we let x as 0 plus h, and we know that fraction part of h is simply h. So it will be this limit h tends to 0 10 square h upon h square plus 2h, and then greatest integral function of 0 plus h is simply 0. So it will be this 10 square h upon h square, which is 1. So this right hand limit, it is 1, and that means this option A, it is correct. Now if we look at its left hand limit, it will be limit x tends to 0 negative, then under root of fraction part of x into cot of fraction part of x. Now here we'll write x as 0 minus h, and fraction part of minus h is simply 1 minus h. So this limit will be limit h tends to 0 positive under root of 1 minus h into cot 1 minus h. Now we put h as 0, this limit will be under root of cot 1. So that means this option B, it is incorrect. Now if you look at this option C, it will be this cot inverse of square of left hand limit, which is cot 1, and that is 1. This option C is also correct, and option D is incorrect as limit does not exist. Now here the question is, we need to solve this limit x tends to 0 sin 6x square upon log cos 2x square minus x. Now what we'll do is, we'll write this as limit x tends to 0 sin 6x square upon 6x square, and here will be this 6x square upon log cos 2x square minus x. Now this is standard limit 1, and this is 0 upon 0 form, and for this we'll use L'Hopital's rule. So we can write this as limit x tends to 0, and that will be 12x, and here it is 1 upon cos 2x square minus x, and this is minus sine 2x square minus x into 4x minus 1, which we can write as limit x tends to 0 minus 12x upon 10 2x square minus x into 4x minus 1, which is still 0.01. Now what we'll do is we'll multiply and divide everything with 2x square minus x. Now this x will cancel. This is standard limit 1. So we put this limit, we'll get minus 12. This is minus 1. And here also will be this minus 1. So answer to this limit is minus 12. And that's your option B. Now here the question is, we need to find this limit x tends to pi by 2. This greatest in a function of x minus pi by 2 upon cos x. Now here what we'll do is we'll find left hand limit and right hand limit. First we'll find its right hand limit, which is limit x tends to pi by 2 positive x minus pi by 2 upon cos x, and for this we'll let x as pi by 2 plus h. Now we take x as pi by 2 plus h, we'll get this as limit h tends to 0 positive, and here will be this h upon, now cos pi by 2 plus h is minus sin h. Now we know that sin h is less than h and it is greater than 0, then h tends to 0, or we can write h upon sin h, it will be greater than 1. Then we multiply it with minus, we can write minus h upon sin h, it is less than minus 1. And if this value is less than minus 1, then its greatest inter function will be simply minus 2. So its right hand limit will be minus 2. Now we'll come to its left hand limit. So its left hand limit will be a limit x tends to pi by 2 negative, and there will be x minus pi by 2 upon cos x. Now here we let x as pi by 2 minus h. So it will be this limit h tends to 0 positive, and this is minus h upon sin h, which is same expression. So this limit is also minus 2. So the value of this limit is minus 2, and that's your option C. Now here in this question we are given fx and gx, and we need to find this limit x tends to 1 f of gx. Now first we'll consider its left hand limit. Now for left hand limit, x tends to 1 negative. Now this x, it goes into gx. Now when x is less than 1, definition of gx is 3 minus x. So this g1 negative, it will be 3 minus and 1 minus h, which is 2 plus h, and which is greater than 2. Now this gx, it will go into fx, and when x is greater than 2, fx is x square plus 2. So this 2 will go to x square plus 2, and there will be 2 square plus 2, which is 6. So its left hand limit is 6. Now if we look at its right hand limit, it will be x tends to 1 positive. Now 1 positive goes to gx. So g1 positive, it will be this 2 into 1 plus h, which again is 2 plus h, which is greater than 2, and which again will go to x square plus 2, which is 6. So answer to this limit is 6. Now here the question is, evaluate this limit n tends to infinite 1 into 2x plus 2 into 3x up to n into n plus 1x upon n cube. Now we can write this as limit n tends to infinite. This summation r varies from 1 to n, greatest new function of r plus 1 into x upon n cube, and we know that greater function of x is equal to x minus fractional part of x. So we'll write this as limit n tends to infinite, summation r varies from 1 to n r plus 1 into x minus this summation r varies from 1 to n fractional part of r plus 1x divided by n cube. Now we know that any fraction part x function will lie between 0 and 1. Since we have these n summations of 1, so all these n summations, this will be less than n. So if it is less than n, and when it is divided by n cube, this limit when n tends to infinite will be simply 0. So this limit for the second part is 0. So we just have to solve this first part. Now we can write this as limit n tends to infinite, and this is summation r square plus summation r into x upon n cube. Now this is limit n tends to infinite. This is n plus 1 to n plus 1 divided by 6 plus n plus 1 by 2 into x upon n cube. Now since this is infinite limit, highest power of n in the numerator is n cube, and the denominator also it is n cube. So answer to this limit is coefficient of n cube in the numerator and denominator. In the numerator, coefficient of n cube is 2x by 6, which is x by 3, and the denominator it is 1. So answer to this limit is simply x by 3, and that is the answer to this question. Now here the question is, we need to find this limit x tends to 0 f of g of hx. Now first we will take limit x tends to 0. Now limit x tends to 0, the value of x will go into h, so it will go into this x. So whether it is 0 minus or 0 plus, so in both these cases, left hand limit as well as in right hand limit, this mod of x will go to mod of 0 plus minus h, which is mod of h, and it is greater than 0. Now if it is greater than 0, the value from h goes to g, which is x plus 1. So it will be h plus 1, which is greater than 1, and this h plus 1 will go into fx, and when x is greater than 1, it is x minus 1. So it will go to h plus 1 minus 1, which is h, and that is nothing but 0. So answer to this limit is 0. Now here the question is, we need to find this limit x tends to a negative mod of x cube by a minus greatest function of x upon a whole cube. Now what we'll do is, we'll let x as a minus h. So it will be this limit h tends to 0 positive mod of a minus h cube upon a minus, and this is a minus h upon a. So it will be this limit h tends to 0 positive. Now this is mod a cube upon a, and a is greater than 0. So it will be this a square minus, and here it is 1 minus h upon a, which is less than 1. And get a function of value which lies between 0 and 1 is 0. So answer to this limit is simply a square, and that's your option C. Now the question is, if alpha and beta are the roots of this quadratic equation, then this limit x tends to alpha 1 plus ax square plus bx plus c to the power 1 upon x minus alpha. Now, since alpha is root of this equation, this expression will be 0. So this is 1, and then 1 upon 1 minus 0 is infinite. So this is 1 to the power infinite form. We can write this as e to the power limit x tends to alpha, and then gx, which is 1 upon x minus alpha into fx minus 1, which is ax square plus bx plus c. Now we know that we can write this quadratic equation in factorized form. So we can write this as a into x minus alpha into x minus beta upon x minus alpha. Now x minus alpha will cancel. Now we'll put x as alpha, so it will be this e to the power a alpha minus beta. And that's your option C. Now the question is, we need to solve this limit x tends to 0, greatest new function of 1 minus e to the power x sin x upon mod x. Now since this question has both greatest integer and mod with change definition at 0, we have to use left hand limit and right hand limit. So first we'll write its left hand limit. So its left hand limit will be limit x tends to 0 negative 1 minus e to the power x sin x upon mod x. Now we let x as 0 minus h, so it will be this limit h tends to 0 positive, and it will be 1 minus e to the power minus h, and here it will be this sign minus h upon mod of minus h, which we can write as get a function of 1 minus e to the power minus h into minus sin h upon h. Now we know that if h tends to 0 positive, then e to the power minus h, it lies between 0 and 1. Then 1 minus e to the power minus h will be greater than 0 but less than 1. In the same way, we know that if h is positive, then h is nearly 0, then sin h is less than h, and it will be greater than 0, or we can say sin h upon h will lie between 0 and 1. And we multiply it with minus, then we can write value of sin h upon h will lie between minus 1 and 0. So one of them is positive and one of them is negative. So their product negative, and both of them, the value lie between 0 and 1. So value of this product 1 minus e to the power minus h into sin h upon h will lie between minus 1 and 0. And if this value lies between minus 1 and 0, then its greatest new function will be minus 1. So its left hand limit is minus 1. Now we'll come to its right hand limit. Now for its right hand limit, we'll write limit h tends to 0 positive, and then it will be greater function of 1 minus e to the power h, and here it will be this sin h upon h. Now in this case, e to the power h will be greater than 1. So 1 minus e to the power h will lie between minus 1 and 0, whereas sin h upon h will lie between 0 and 1. Now again this product 1 minus e to the power h into sin h upon h, it will lie between minus 1 and 0, So value of this greatest function again is -1. Now since left hand limit is -1 and right hand limit is -1, value of this limit is -1, and that's your option A. Now here this first question is we need to find this limit, which is limit x tends to 0 positive log sin x to the base sin x by 2. Now we'll write this as limit x tends to 0 ln of sin x upon ln sin x by 2, which is log 0 upon 0, that is infinity upon infinity form. We can use L'Hopital's rule. So it will be this limit x tends to 0, and here will be this 1 upon sin x into cos x, and this one is 1 upon sin x by 2 into cos x by 2 into 1 by 2. Now we can write this as limit x tends to 0 10x by 2 upon 10x, and this is 1 by 2. We'll multiply and divide everything with x. Now this is 1, this is 1, so value of this limit is 1, and that's your option A. Now if we look at this second one, then L is this limit x tends to infinite sine under root of x plus 1 minus sine under root of x. Now we'll use the formula sin c minus sin d. So it will be this limit x tends to infinite 2 sine c minus d by 2. So it will be under root of x plus 1 minus under root x by 2 into cos under root of x plus 1 plus under root of x by 2. Now we'll rationalize this. If we rationalize this, we can write it as limit x tends to infinite, and will be 2 sine, and here will be 1 upon 2 under root of x plus 1 plus under root x, and here will be this cos under root x plus 1 plus under root x by 2. Now when x tends to infinite, this is 1 upon infinite, so it will be sin 0 is 0 into cos infinite, and cos infinite is oscillating value -1 to 1. Now 0 into anything finite is finite, so answer to this limit is 0. So value of L is 0. Now what about if we take this limit as x tends to minus infinite? Now if x is negative, then in that case under root x will not be defined. So answer to this question will be L is 0 and M is undefined, and that's your option B. Now here the question is, find this limit theta tends to 0 greater than a function of n sin theta upon theta and plus n tan theta upon theta. Now we know that sin theta is less than theta is less than tan theta when theta tends to 0 positive. Or we can write when theta tends to 0, sin theta upon theta is less than 1 and it is less than tan theta upon theta. So basically sin theta upon theta, it is nearly 1 minus h, when tan theta upon theta is nearly 1 plus h dash. Now we multiply it with n, then we can write n sin theta upon theta, it will be n minus nh, and in the same way n tan theta upon theta will be n plus n into h dash. Now we take its greatest function of n Sin theta upon theta. Now this is n minus some small value. So it will be n negative, which is n minus 1, and get a function of n tan theta upon theta. This is n plus small h, which is n. Now we add them. This limit theta tends to 0, n sin theta upon theta plus n tan theta upon theta. It will be n minus 1 plus n, which is 2n minus 1. So answer to this limit is 2n minus 1, and that's your option C. Now here the question is, we need to solve this limit. Limit x tends to 0, 1 minus cos x into under root of cos 2x upon x square. Now we'll solve this question using expansion. So we'll write this as limit x tends to 0, 1 minus, and then it will be 1 minus x square upon 2, and this one is 1 minus 2x square upon 2, and that will be 2x square whole to the power 1 by 2. Now again we'll use binomial expansion of 1 minus x to the power n. So it will be this limit x tends to 0, 1 minus, and this is 1 minus x square by 2, and here will be this 1 minus x square upon x square. Now we simplify this, we'll get this as limit x tends to 0, and this is 1 minus, and will be 1 minus x square by 2 minus x square. So that will be minus 3x square by 2 and other higher powers of x divided by x square. Now this 1 and 1 will cancel, minus 1 is plus, x square will cancel. So answer to this limit will be simply 3 by 2. Now here we need to find this limit 1 upon under root n square plus 1 upon under root n square plus 1 up to 1 upon under root n square plus 2n. Now for this limit we know that under root of n square will be less than under root of n square plus r, and will be less than or equal to under root of n square plus 2n, where value of r varies from 1 to 2n. Now if we take its reciprocal, then we can write 1 upon under root of n square plus 2n will be less than or equal to 1 upon under root of n square plus r, and will be less than 1 upon under root of n square. Now we take this summation, r varies from 1 to 2n will be this 2n upon under root of n square plus 2n will be less than this summation, r varies from 1 to 2n 1 upon under root of n square plus r, and it will be less than 2n upon under root of n square. Now we take this limit n tends to infinite. Now here highest power is 1, and here also highest power is 1. So this left hand side limit is 2. On the right hand side limit is 2. So value of this limit, which is actually the given limit, it will also be 2 using sandwich theorem. So answer to this question is option D. Now here the question is, we need to find the value of this limit x tends to 0 cos of sin x minus cos x upon x to the power 4. Now what we'll do is, we'll use the formula for cos c minus cos d. So it will be 2 sin c plus d by 2, and there will be sin x plus x by 2 into sin d minus c by 2. So there will be sin x minus sin x by 2. Now what we'll do is, since it is sin 0 and sin 0, we'll multiply and divide it with x plus sin x by 2 and x minus Sin x by 2, we have this x to the power 4, and here will be this x square minus sin square x whole divided by 4. Now this is 1 and this is 1 and this 2 will cancel. So we'll write this as limit x tends to 0, x square minus sin square x upon 2 x to the power 4. Now we'll write this as limit x tends to 0, x plus sin x into x minus sin x upon 2x to the power 4, and we'll use series expansion of sin x. So it will be this limit x tends to 0. Now this is x plus x minus x cube upon factorial 3, and here will be this x minus x cube upon factorial 3 upon 2x to the power 4. Now here x and x will cancel, minus and minus will be this plus. So lowest power of x in the denominator is 4 and lowest power of x in the numerator is also 4. So answer to this limit is coefficient of x to the power 4. Now this is 2x, so it will be this 2 into factorial 3, which is 1 by 6, and then it will be this 2. So answer to this limit is 1 by 6, and that's your option B. Now here the question is, we need to solve this limit, which is limit x tends to infinite. Now we'll rearrange this a bit. So we'll write this as 2 to the power x to the power n upon e to the power x minus 3 to the power x to the power n upon e to the power x upon x to the power n upon e to the power x. Now what we'll do is, we'll let x to the power n upon e to the power x as h. Now when x tends to infinite, x to the power n upon e to the power x will be infinity upon infinity form. Now if we differentiate this n times, there will be factorial n upon e to the power x, and there will be factorial n upon infinite, which is 0. So when x tends to infinite, this h, it tends to 0. So it will be this limit h tends to 0, 2 to the power h minus 3 to the power h upon h. Now this is 0 upon 0 form. Now if we use L'Hopital's rule, then we can write limit h tends to 0. This is 2 to the power h log 2 minus 3 to the power h log 3 upon 1. And if we put this limit h tends to 0, this is log 2 by 3, and that's your option B. Now here the question is, we need to solve this limit n tends to infinite 1 into this summation k varies from 1 to n, plus 3 into summation k varies from 1 to n minus 1 up to 2n minus 1 into 1 upon n to the power 4. Now since this is infinite limit and the highest power of n in the denominator is 4, and since the answer is non-zero finite, highest power of n in the numerator must also be n to the power 4. So basically answer to this limit will be coefficient of n to the power 4 in this series, which is this summation r varies from 1 to n 2r minus 1, this summation k varies from 1 to n minus r plus 1 into k. So essentially we are looking for coefficient of n to the power 4 in this series. Now this is summation r varies from 1 to n 2r minus 1, and here it will be n minus r plus 1, n minus r plus 2 whole divided by 2. Now we can write this as summation r varies from 1 to n 2r minus 1, and here will be this r square minus r 2n plus 3 and plus n plus 1 into n plus 2 whole divided by 2. Now we can further expand it as this summation r varies from 1 to n, and there will be 2r cube minus 2r square into 2n plus 3 plus n plus 1 n plus 2 into 2r, and then it will be minus r square r 2n plus 3 and minus n plus 1 into n plus 2 whole divided by 2. So it will be this 1 by 2, and then this summation 2r cube where r varies from 1 to n, and then we have this r square here plus r square into minus 4n minus 6 minus 1. So there will be minus 7 plus n plus 1. There will be this summation r square n plus 1 n plus 2 into 2 into summation r 2n plus 3 into summation r minus summation n plus 1 into n plus 2. Now this is 1 by 2 and this is 2, and summation r cube is n plus 1 by 2 whole square, and here it is minus 4n plus 7, and this is n plus 1 2n plus 1 by 6 plus this is n plus 1 n plus 2 into 2, and this is n plus 1 by 2 2n plus 3 n plus 1 by 2 and minus n plus 1 n plus 2 into n. Now here we are looking for coefficient of n to the power 4. Now in this case it will be this 2 into 1 by 2. So there will be this 1 by 2. Now here this coefficient will be 4 into 2, 8 divided by 6. So there will be minus 4 by 3 and plus, here this 2 and 2 will cancel, plus 1, and there is no other term containing n to the power 4. Now this is 1 by 2 and then 1 by 2 minus 4 by 3 plus 1. So there will be minus 1 by 3 and there will be 1 by 6, which is 1 by 12. So answer to this limit is 1 by 12, and that is what we need to prove in this question. Now here the question is, we are given this function fx and it has limit m tends to infinite, limit n tends to infinite, cos to the power 2 factorial n pi x to the power m. So we have actually rearranged it. Now we are taking two cases. Case 1, if x is rational. Now if x is rational, then x is of the form some p by q, where q is an integer, and when we multiply this factorial n with pi into x, which in this case is p by q, as n tends to infinite, this n will contain q at some place. So this q and q will cancel. So basically it will be an integral multiple of pi. And if it is an integral multiple of pi, then in that case cos factorial n pi p, it will take the value either plus 1 or minus 1. So in this case, when x is rational, this fx will simply be plus or minus 1 to the power 2m, which is 1. So when x is rational, the value of fx is 1. Now if x is irrational, in that case, this cos factorial n pi p, it cannot be plus or minus 1. That means the value of cos square factorial n pi x, it will lie between 0 and 1. And if this value lies between 0 and 1, then this limit m tends to infinite, cos square factorial n pi x to the power m will be 0, because we know that a to the power infinite is 0 if a lies between 0 and 1. So if it is rational, function takes the value 1, and if it is irrational, function is going to take the value 0. Now here the question is, we need to find this limit, which is limit x tends to 0 positive, limit n tends to infinite, and then this summation r square into sine x to the power x greater than a function where r varies from 1 to n whole divided by n cube. Now we can write greatest in a function of x as x minus fractional part of x. So it will be this limit x tends to 0 positive, and it will be this limit n tends to infinite, and then we can write this as summation r varies from 1 to n r square sine x to the power x upon n cube minus this limit n tends to infinite fractional part of r square sine x to the power x upon n cube. Now we know that any fractional part function, it will lie between 0 and 1. So therefore this summation r square sin x to the power x, it will always be greater than or equal to 0, but it will be less than n. Now we divide everything with n cube, and if we take this limit n tends to infinite, left hand side is 0, right hand side is 0, then from sandwich theorem we can say that the value of this limit will be 0. So in that case, this limit will be limit x tends to 0 positive, limit n tends to infinite, and this is sin x to the power x, and then summation r square, and summation r square is n plus 1 2n plus 1 divided by 6. Now this is infinite limit. Now highest power of n in the numerator is 3, and highest power of n in the denominator is also 3. So answer to this limit will be coefficient of n cube in the numerator and denominator. So it will reduce to a limit x tends to 0 positive 2 sin x to the power x upon 6, which is 1 by 3 sin x to the power x. Now we have to solve this limit in x. So it is this limit x tends to 0 positive sin x to the power x whole divided by 3. Now this is 0 to the power 0 form. We can write this as 1 by 3 e to the power limit x tends to 0 x log sin x, or we can write this as 1 by 3 e to the power limit x tends to 0 log sin x upon 1 by x. Now this is infinity upon infinity form. Now if we use L'Hopital's rule, we can write this as 1 by 3 e to the power limit x tends to 0, and this is 1 upon sin x into cos x, and then it will be minus 1 upon x square. So this is 1 by 3 e to the power limit x tends to 0 minus this is x upon sin x, and then into x cos x. X upon sin x is 1 and x is 0, so this is e to the power 0 and e to the power 0 is 1. So answer to this limit is 1 by 3. Now here the question is, we are given two functions, and one of them is fx, which is this limit n tends to infinite cos x upon under root n to the power n. Now the first thing that we do in limits is to identify its form. Now when n tends to infinite, this is cos 0 is 1, and then to the power n is infinite, so it is 1 to the power infinite form. We'll use the shortcut directly, so it will be this e to the power limit n tends to infinite. Now this is n into cos x by under root n minus 1. Now we'll write this as e to the power limit n tends to infinite. We'll take this minus common. It will be 1 minus cos x by under root n, and we'll take this n in the denominator, so we'll write this as under root n square, and then we'll multiply and divide it with x square. Now this is standard limit. This is 1 minus cos x upon x square, which is 1 by 2. So basically this function fx will be e to the power minus x square by 2. So that's our function fx. Now we are given another function which is gx, and gx is minus x to the power 4b, where b is this limit. So we'll solve this limit. B is this limit x tends to infinite. Now we'll rationalize it. If we rationalize it, we'll write x square plus x plus 1 minus x square plus 1 upon under root of x square plus x plus 1 plus under root of x square plus 1. Now this x square will cancel. This 1 will also cancel. Now the highest power in the numerator is x, and in the denominator it is also x. So value of this limit is 1 by 2. And if b is 1 by 2, then this function gx, it will be minus x square. So we have our fx and gx. So fx is e to the power minus x square by 2. That's your option B. And gx is minus x square. Now it says number of solutions of fx plus gx equals 0. So we have to find number of solutions of fx plus gx equals 0. Now this is e to the power minus x square upon 2, and then minus x square equals 0. So you can write this as e to the power minus x square by 2 equals x square. So we'll use graph for this. Now if we draw the graph of e to the power minus x square, it will be this graph, and x square is parabola opening upwards. So these two graphs, they'll intersect at 2 points. Therefore, it'll have 2 solutions, which is your option A. So answer to this question is B, A and A. Now here the question is, we need to find this limit when x tends to 0. So this is L, and L be this limit x tends to 0 sin x to the power 1 by x, and plus this limit x tends to 0 1 by x to the power sin x. Now this is 0 to the power infinite form, and this is infinity to the power 0 form. Now basically 0 to the power infinite is not an indeterminate form. So we'll actually write this as e to the power limit x tends to 0 log sin x upon x, and plus this limit x tends to 0 e to the power limit x tends to 0 sin x, and this is log 1 by x. Now first we'll check its form. So this is log 0. Log 0 is minus infinite, and minus infinite upon 0 is actually minus infinite. So this is e to the power minus infinite, and e to the power minus infinite is 0. So value of this first limit is 0. That means this L is simply the second limit, which is limit x tends to 0, and this is e to the power limit x tends to 0. We'll write this as minus log x upon cosec x, which is infinity upon infinity form. Now we use L'Hopital's rule, so it will be this e to the power limit x tends to 0, and this is minus 1 by x, and this is minus cosec x into cot x. Minus and minus will cancel, so it will be this e to the power limit x tends to 0 sin x into tan x upon x. Sin x upon x is 1 and tan x is 0. So it will be this e to the power 0. That means value of this limit is simply 1. And that's your option C. Now here the question is, we need to find this limit, which is limit x tends to pi by 2 1 minus tan x by 2 upon 1 plus tan x by 2, and this is 1 minus sin x upon pi minus 2x whole cube. Now we can write this as limit x tends to pi by 2. Now this is 10 pi by 4 minus 10 x by 2. So it will be this 10 pi by 4 minus x by 2. It will be 1 minus sin x upon. We'll take 2 common. So it will be this 8 and then pi by 2 minus x whole cube. Now what we'll do is we'll let x as pi by 2 minus h. So now we can write this limit as limit h tends to 0, and this is 10 pi by 4 minus x by 2, which is pi by 4 minus h by 2. So this is 10 h by 2. Now 1 minus sin pi by 2 minus h is cos h, and it will be this 8 h cube. Now we can write this as limit h tends to 0, 10 h by 2, and this is 8. We'll take this 1h here and then 1 minus cos h upon h square. Now here we'll multiply by 2 and divide by 2. Now this is 1 and this is 1 by 2. So this limit will be 1 by 32. And that's your option C. Now here the question is, we need to solve this limit, which is limit x tends to infinite. This is log x to the power n, which is n log x minus greatest new function of x upon greatest new function of x. Suppose this is limit L. Now this L is limit x tends to infinite. We write this as n log x upon greater function of x minus 1. Now we know that we can write greatest new function of x as limit x tends to infinite, and it will be n log x, and this is x minus fraction part of x minus 1, or we'll write this as limit x tends to infinite n log x upon x divided by 1 minus fraction part of x upon x minus 1. Now we'll solve these two limits. Limit x tends to infinite log x upon x, which is infinity upon infinity form. Now if we use L'Hopital's rule, it will be this limit x tends to infinite, and this is 1 by x upon 1, which is 0. So this limit in the numerator will be 0, and we'll solve the second limit, which is limit x tends to infinite fraction part of x upon x. Now we know that fractional part of x will always lie between 0 and 1, and we divide it with x, so it will be this fraction part of x upon x less than 1 by x. Now we take this limit x tends to infinite, it will be this 0, and then limit x tends to infinite fraction part of x upon x, and it will be 0. Then from sandwich theorem we can say that the value of this limit will also be 0. So answer to this limit is 0 minus 1, which is simply minus 1. And that's your option A. Now here the question is, we are given this function f(x) when greater function of x is unequal to 0, and it is 0 for greater function of x equals 0. Now we need to find limit x tends to 0, fx is equal to what? Now, if we find its left-hand limit will be limit x tends to 0 negative x square plus sine get a function of x upon get a function of x. Now we'll take x as 0 minus h, and we know that when x is 0 minus h, then get a function of minus h is simply minus 1. So this limit, it will be 1 minus sine 1 upon minus 1, which is minus 1 plus sine 1. So for this function, left hand limit is minus 1 plus sine 1. Now if we look at its right hand limit, its right hand limit will be limit x tends to 0 positive fx. Now when x tends to 0 positive, then get a function of x is equal to 0. And if get a function of x is 0, value of this function is 0. So for this function, right hand limit at 0 is 0. Left hand limit is minus 1 plus sine 1, and right hand limit is 0. So answer to this question should be this limit does not exist. Now here the question is, we need to solve this limit, and this limit is, suppose we'll write this limit as L equals limit x tends to a, and then LB this a to the power 1 by 2 plus x to the power 1 by 2 upon a to the power 1 by 4 minus x to the power 1 by 4 to the power minus 1, and then minus 2 ax to the power 1 by 4 upon, and this is x to the power 3 by 4 minus a to the power 1 by 4 x to the power 1 by 2 plus a to the power 1 by 2 x to the power 1 by 4 minus a to the power 3 by 4 whole to the power minus 1, and then minus, this is root 2 to the power log 4a and whole to the power 8. Now first we'll simplify this. Now this is 2 to the power. Now this is 1 by 2, and 2 square is also 1 by 2. So this is 2 to the power log 2 and a to the power 1 by 4. So this expression is nothing but this is a to the power 1 by 4. Now what we'll do is, we'll actually let a to the power 1 by 4 as capital A and x to the power 1 by 4 as capital X. And we can write this L as this limit, and here it will be a square plus x square upon a minus x to the power minus 1, and then minus, and this is 2 ax upon x cube minus ax square plus a square x minus a cube whole to the power minus 1, and then minus a whole to the power 8. Now this is this limit, and then if we take this reciprocal, we can write this as a minus x upon a square plus x square, and this is minus 2ax, and if we factorize this, we can factorize this as x minus a into x square plus a square whole to the power minus 1 minus a whole to the power 8. Now we simplify this, we can write this as limit, and then it will be x minus a into x square plus a square, and here it will be minus x minus a square minus 2ax to the power minus 1 minus a whole to the power 8. Now it will be this limit, and then it will be this minus x square plus a square upon x minus a and x square plus a square whole to the power minus 1 minus a to the power 8. Now x square plus a square will cancel, and if we take this reciprocal, then it will be this limit a minus x minus a to the power 8. Now a and a will cancel, so this is limit capital X to the power 8. Now capital X is small x to the power 1 by 4, so it will be this limit x tends to a x to the power 2, and which is a square. So answer to this limit is a square, and that's your option C. Now we are given this function fx and we need to solve this limit. Now we'll take certain cases. Case 1, if x is plus 1, then the value of f1 will be log 3 minus sine 1 by 2, because in that case this 1 to the power 2n will be 1. And if x is minus 1, then we can write f minus 1 as, now this is log 2 minus 1 is log 1, which is 0, and then minus 1 square is 1, so it will be this sine 1 by 2. So that is the value of this function at 1 and minus 1. Now if x lies between minus 1 and plus 1, in that case this x to the power 2n, it approaches 0 as n tends to infinite. So in that case this function fx will be log 2 plus x minus 0 upon 1 minus 0, which is simply fx is log 2 plus x. And if x square is greater than 1, then this limit x to the power 2n will approach infinite, and if it approaches infinite, we'll divide everything with x to the power 2n. And if we divide everything with x to the power 2n, then in that case our fx, it will be simply minus sin x. Now we'll start solving these limits. Now this first one is limit x tends to 1 positive fx. Limit x tends to 1 positive fx. Now when x is greater than 1, this is minus sin x, so it will be this minus sin 1, and limit x tends to 1 negative. When x is less than 1, this is log 2 plus x. So this fx is log 2 plus x, which is log 3. That means this option B is correct. Now fx is clearly discontinuous at x equal to 1. F1 positive is not sin 1, it is minus sin 1. Option C is incorrect. And limit x tends to 1 negative, it exists and is equal to log 3. So the only option correct is this option B. Now here the question is, we need to find the value of this limit, which is limit n tends to infinite cos x by 2 into cos x by 2 square up to cos x by 2 to the power n. Now what we'll do is, we'll multiply and divide everything with 2 to the power n sin x upon 2 to the power n. So it will be this 2 to the power n sin x upon 2 to the power n. Now if we take 2 sin x upon 2 to the power n into cos x upon 2 to the power n, this is 2 sin theta cos theta, which is sin x upon 2 to the power n minus 1. So what will happen is, we'll keep getting this formula for sin 2x, which in the end will be 2 cos x by 2 and sin x by 2, which is nothing but, which is limit n tends to that sin x upon 2 to the power n sine x upon 2 to the power n. Now this is n tends to infinite, so 2 to the power infinite is infinite, so this is infinity into 0 form. So what we'll do is we'll write it in standard limit, so it'll be this limit n tends to infinite, and this is sine x, and we'll write this as sine x upon 2 to the power n divided by 1 upon 2 to the power n. Now we'll multiply and divide it with x. Now this is sine 0 upon 0, which is indeterminate form, whose limit is 1. So answer to this limit is simply sine x upon x, and that's your option B. Now this is a very conceptual question. It says if limit x tends to a fx into gx exists for any function f, then which of the following is true? Now clearly answer has to be both these limits fx and gx, they may not exist. And if we take very simple example, suppose this is one of the limit is limit x tends to 0 mod x upon x, and we know that this limit does not exist as this value is minus 1 and plus 1. And suppose the other limit is limit x tends to 0 x upon mod x, which again does not exist, again which is minus 1 and plus 1. But if we multiply them, then it becomes a constant function for which this limit is going to exist. So if this fx into gx limit exists, both of them may not even exist, and that's your option B. Now here the question is, we need to solve this limit x tends to 0 x to the power 8 into greatest integral function of 1 by x cube. Now we know that greater function of x, it is always less than equal to x, but it is greater than x minus 1. So we can write greater function of 1 by x cube will be less than equal to 1 by x cube, but greater than 1 by x cube minus 1. Now we'll multiply it with x to the power 8. Now if we multiply it with x to the power 8, it will be x to the power 5 minus x to the power 8 and less than x to the power 8 into greatest function of 1 by x cube. It is less than equal to x to the power 5. Now if we take this limit x tends to 0, then in that case this left hand side function limit is 0 and limit of the function on the right hand side is 0. Then using sandwich theorem, value of this limit, it must also be 0. So this is 0, which is a rational number and which is also an integer. So the correct options are B, C and D. Now here the question is, we are given this determinant delta x and we need to find the value of this limit h tends to 0 root 3 delta pi by 3 upon h square. Now if we look at this limit h tends to 0 root 3 upon h square delta pi by 3 will be this 10. We'll put x as pi by 3 later, so we'll write this as 10x plus h 10 x plus 2h 10 x plus 2h 10x 10 x plus h, and here it is 10 x plus h 10 x plus 2h and 10x. Now what we'll do is we'll write C3 as C3 minus C2 and C2 as C2 minus C1. We can write this as this limit, say L, and it will be this limit h tends to 0. This is root 3, and here we have 10x 10 x plus 2h and 10 x plus h. Here will be 10 x plus h minus 10x. This is 10x minus 10 x plus 2h, and here will be 10 x plus 2h minus 10 x plus h. In the same way, here will be 10 x plus 2h minus 10x plus h. This is 10x plus h minus 10x, and here will be this 10x minus 10x plus 2h. And then we have this h square, and what we'll do is we'll take 1 upon h in column 2 and 1 upon h in column 3. Now, if we look at these limits, now this limit h tends to 0, 10 x plus h minus 10x upon h. This is 0 upon 0 form. If we differentiate this, we'll get this as secant square x. And the second limit h tends to 0, 10x minus 10 x plus 2h upon h, which again is 0 upon 0 form. If we differentiate this, we'll get this as minus 2 secant square x. And finally this third one, limit h tends to 0, 10 x plus 2h minus 10 x plus h upon h. And we differentiate and put h as 0, we'll get this as secant square x. So using these limits, we can write this limit L as root 3, and then it will be this 10x, here will be this secant square x, and here it is x plus 2h. When h tends to 0, it will again be 10x, and here will be minus 2 secant square x, and this is secant square x. Now this again is 10x, this is secant square x, and this is minus 2 secant square x. Now we'll take R3 as R3 minus R2 and R2 as R2 minus R1. So this limit will be root 3, and then this is 10x secant square x, and this is 10x minus x0. This is minus 3 secant square x, and this is minus 3 secant square x, and here will be this 0 minus 3 secant square x, and it will be this 0. So if we expand it about this first column, we'll get this as root 3 into 10x into 9 secant to the power 4x. Now we need to find this limit when the value of x is pi by 3. So if we put x as pi by 3, this limit will be 9 root 3. Now 10 pi by 3 is root 3, and secant pi by 3 is 2. So that will be 2 to the power 4. So this limit will be 27 into 16, which is 432. In this question, we are given these 4 functions, and we need to find these 2 limits. Limits x tends to 1 and limit x tends to 0. Now, if we look at this first function, we are given fx is x into signum function of x minus 1. Now, we know that signum x minus 1 is minus 1 when x is less than 1. So, it will be this minus x. When x equal to 1, it will be 0. And when x is greater than 1, it will be plus x. Now, if we look at limit x tends to 0 fx, in that case, its definition is simply minus x, which is 0. And if we look at limit x tends to 1 negative fx, it will be this minus x, which is minus 1. And limit x tends to 1 positive fx, it will be this x, which is plus 1. So at x equal to 1, this limit does not exist. So for this first function, at 0, this limit is 0, but at 1, this limit does not exist. Now, if we look at this b, Then we are given this function fx as sine of 10 x square by 2 upon log cos 3x. Now if we take this limit x tends to 0 fx, it will be 0 upon 0 form, and if it is 0 upon 0 form, we can write limit x tends to 0. Now this is cos of sine 10 x square by 2 into cos of 10 x square by 2 into secant square x square by 2 into 2x by 2, and here it will be log is 1 upon cos and cos is sine, so it will be minus 10 3x into 3. Now this is cos 0 is 1, cos 0 is again 1, secant 0 is 1, and here 2 and 2 will cancel. What we'll also do is we'll multiply and divide it with 3. Now this is 3x upon 10 3x, it will be 1. So this limit x tends to 0 fx will be minus 1 by 9. Now what about limit x tends to 1 fx? Now what about limit x tends to 1 fx? Now if we take limit x tends to 1, in that case it will be this sine of 10 square 1 by 2, and then it will be log cos 3, and cos 3 is less than 0. So in that case this function itself is not defined. Now for this c, we are given this function fx as 1 plus 10 inverse 3x to the power 1 by 3 minus 1 minus sine inverse 3x to the power 1 by 3 upon 1 minus sine inverse 2x to the power 1 by 2 minus 1 plus 10 inverse 2x to the power 1 by 2. Now we look at this limit x tends to 1 fx. In that case we'll have this sine inverse 3, and sine inverse 3 is not defined. So this limit x tends to 1, it doesn't make sense in case of this function. The only limit we have to calculate in this case is this limit x tends to 0 fx. So it will be this limit x tends to 0 fx. Now this limit, it will be this limit x tends to 0, and we'll use binomial expansion. So it will be this 1 plus 1 by 3 10 inverse 3x minus 1 minus 1 by 3 sine inverse 3x plus higher powers, and then it will be 1 minus 1 by 2 sine inverse 2x, and then minus 1 plus 1 by 2 10 inverse 2x. Now this 1 will cancel. We can write this as limit x tends to 0. Now this is 1 by 3 10 inverse 3x plus 1 by 3 sine inverse 3x plus higher powers of 10 inverse and sine inverse, and here will be minus 1 by 2 sine inverse 2x minus 1 by 2 10 inverse 2x and higher powers. Now we divide everything with x. This 10 inverse of 3x upon 3x is 1, sine inverse of 3x upon 3x is 1, again sine inverse of 2x upon 2x is 1, and 10 inverse of 2x upon 2x is 1, and all other high powers will be 0. So answer to this limit will be simply minus 1. And finally we have this function fx equals e to the power 1 by x minus 1 e to the power 1 by x plus 1. So this d is fx is e to the power 1 by x minus 1 and e to the power 1 by x plus 1. Now limit x tends to 1 fx has no problem. In that case it will be e minus 1 and e plus 1. But if we look at left hand limit at x equals 0, it will be limit x tends to 0 negative e to the power 1 by x minus 1 upon e to the power 1 by x plus 1. Now this is e to the power minus infinite, and e to the power minus infinite is 0. Then in that case it will be 0 minus 1 and 0 plus 1, which is minus 1. And in that case the right hand limit will be limit x tends to 0 positive e to the power 1 by x minus 1 e to the power 1 by x plus 1, which is infinity upon infinity form. So what we'll do is we'll divide everything with e to the power 1 by x. Then in that case it will be 1 minus 0 and 1 plus 0, which is 1. So in that case left hand limit and right hand limit, they are not equal. So this function fx limit x tends to 0, it does not exist. Now here the question is, we are given two statements. If we look at the statement 2, and statement 2 is limit x tends to infinite, fractional part of x upon x, it is equal to 0. Now we know that any fractional part function will always lie between 0 and 1. Now if we divide everything with x, we can write fractional part of x upon x will be less than 1 by x. Now if we take this limit x tends to infinite, then limit of this function on the left hand side is 0, and limit of this function on the right hand side, which is 1 by infinite, is also 0. Then from sandwich theorem or squeeze play theorem, we can say that this limit x tends to infinite, fractional part of x upon x is equal to 0. That means this statement 2 is correct. Now if we look at this statement 1, then we are supposed to find this limit x tends to 0 positive x upon a and get a function of b by x. Now we can write this as limit x tends to 0 positive, this is x by a, and we can write b by x minus fractional part of b by x. Now we can write this as b upon a minus this limit x tends to 0, and we can rearrange this as 1 upon a b by x, and this is 1 by x. We'll multiply and divide with b also. Now when x tends to 0, 1 by x tends to infinite. Now this statement 2 says if x tends to infinite, then fractional part of x upon x, it is 0. So in that case this limit will be 0. So value of this limit will be simply b by a. So this statement 1 is true, statement 2 is true, and statement 2 explains statement 1. Now here the question is, we are given this limit L, and that is limit x tends to 0, and this is a minus, we'll take this a common, and then it will be 1 minus x square upon a square to the power 1 by 2 minus x square by 4 upon x to the power 4 for all a greater than 0. Now this is 0 upon 0 form. So what we'll do is we'll use series expansion of binomial. So it will be this limit x tends to 0. Now this is a minus, and this is 1 minus 1 by 2 x square by a square, and then plus it will be this n minus 1, and then x to the power 4 upon a to the power 4 divided by factorial 2, and then minus x square upon 4 whole divided by x to the power 4. Now here a and a will cancel, so we can write this limit as limit x tends to 0, and then we have this x square. Now this is minus 1 by 2, and this a and a square, so it will be this minus 1 by 2a minus minus plus, and then minus 1 by 4, and then we'll have minus minus plus 1 by 8 x to the power 4 upon a cube and higher powers of x upon x to the power 4. Now if L is finite, then there should be no x square in this expansion. So this term, it must be 0. So from here we'll get value of a as 2. So value of a, it must be 2, and that's your option A. And if there is no term containing x square, then minimum power in the numerator and denominator is x to the power 4. In that case, value of this limit will be 1 upon 8 a cube, which is 1 upon 8 into 8, which is 1 by 64, and that's your option C. So answer to this question is A and C. Now here we have three limits. This is 1, 2 and 3. First one is this limit x tends to 1 negative 1 minus under root x upon cos inverse x. Now this is 0 upon 0 form. So for the first one, we let x as cos theta. So it will be this limit theta tends to 0 positive, and this is 1 minus under root cos theta upon theta square. Now if we rationalize, we can write this as limit theta tends to 0, 1 minus cos theta upon theta square into 1 plus under root of cos theta. Now this limit is 1 by 2, and this is also 1 plus 1, 2. So value of this limit is 1 by 4. So this value is 1 by 4. Now for the second one, we are given that limit x tends to minus 1 positive sine inverse under root pi minus under root of cos inverse x divided by under root of 1 minus x square. Now this is 0 upon 0 form. So what we'll do is we'll make this as standard function of sine limit. So it will be this minus 1 positive and then sine inverse under root pi minus under root of cos inverse x, and here also will be under root pi minus under root of cos inverse x, and here it will be under root pi minus under root of cos inverse x under root of 1 minus x square. Now this is sine inverse 0 upon 0, which is standard limit whose limit is 1. So it will be this limit x tends to minus 1 positive under root pi minus under root of cos inverse x upon under root of 1 minus x square. Now what we'll do is we'll rationalize this. If we rationalize it, we can write this as limit x tends to minus 1 positive, and this is pi minus cos inverse x upon under root of 1 minus x square, and then here will be this under root pi plus under root of this cos inverse x, and cos inverse minus 1 is pi. So this value will be 1 upon 2 root pi. So we can write this as 1 upon 2 root pi, and then this limit x tends to minus 1 positive pi minus cos inverse x upon under root of 1 minus x square. Now we know that cos inverse minus x is pi minus cos inverse of x. So we can write this as 1 upon root 2 pi, and then this limit x tends to minus 1 positive cos inverse minus x upon 1 minus x square. Now what we'll do is we'll let x as minus cos theta. Now if we let x as minus cos theta, then this limit, it will be 1 upon 2 root pi. Now when x tends to minus 1, cos theta tends to 1, that means theta tends to 0. So it will be this limit theta tends to 0 positive, and this is theta upon under root of 1 minus cos square theta, which is sine square theta. So it will be this 1 upon 2 root pi limit theta tends to 0 positive theta upon mod of sine theta. And since we have theta tends to 0 positive, this value will be 1 upon 2 root pi. So answer to the second limit is 1 upon 2 under root pi. Now this third one is limit x tends to pi by 2 under root of 10x minus sine of tan inverse of 10x divided by 10x plus cos square of 10x. Now if we look at the graph of tan inverse of 10x, we know that tan inverse of 10x is x if x lies between minus pi by 2 and plus pi by 2, and if it lies between pi by 2 and 3 pi by 2, then this value is pi plus x. So here we'll have to take two separate limits. Left hand limit is limit x tends to pi by 2 negative, and then it will be this under root of 10x minus. Now in this case, when x is less than pi by 2, then 10 inverse of 10x is x. So it will be 10x minus sine x upon 10x plus cos square 10x. Now this is infinity upon infinity form. So what we'll do is we'll divide everything with 10x. So it will be this limit x tends to pi by 2 negative, and it will be 1 minus cos x, and here will be 1 plus cos square 10x upon 10x. As x tends to pi by 2, cos 90 is 0, and then this oscillating value from 0 to 1 upon infinite will be 0. So this is 1. So left hand limit in this case is 1. Now we'll find its right hand limit. Now for right hand limit, limit x tends to pi by 2 positive, it will be under root of 10x and then minus sine. Now in this case, 10 inverse of 10x is pi plus x. And here will be this 10x plus cos square 10x. Now sin pi plus theta is minus sin theta. So what we'll do is we'll write this as limit x tends to pi by 2, and we'll divide everything with 10x. So it will be 1 plus cos x upon 1 plus cos square 10x upon 10x. Now cos 90 is 0 and 1 upon 10 infinite is also 0. So this again is 1. So in both the cases, this limit is 1. So this limit exists and is equal to 1. Then the question is we need to evaluate this limit. Now since it has fraction part of x and fraction part of minus x, we need to use left hand limit and right hand limit. Now if we take its left hand limit, it will be limit x tends to 0 negative sin x minus x square minus fraction part of x, fraction part of minus x upon x cos x minus x square minus fraction part of x into fraction part of minus x. Now when x tends to 0 negative, we let x as 0 minus h, and we know that fraction part of h is h and fraction part of minus h is 1 minus h. So it will be this limit x tends to 0 negative. Now this is minus sin h minus h square, and then minus it is 1 minus h into h, and here will be this minus h cos h minus h square, and then minus 1 minus h into h, which is this limit x tends to 0 negative minus sin h. Now this is minus h upon minus h cos h minus h. Now we cancel this minus. Now we can write this as limit h tends to 0 positive sin h upon h plus 1 divided by 1 plus cos h, which is 2 upon 2, that is 1. So left hand limit in this case is 1. Now we'll find its right hand limit. Now for right hand limit, it will be limit x tends to 0 positive sin x minus x square minus fraction part of x, fraction part of minus x upon x cos x minus x square minus x minus fraction part of minus h. Here we'll take x as 0 plus h, and then again fraction part of h is h and fraction part of minus h is 1 minus h. So it will be this limit h tends to 0 positive sin h minus h square minus h 1 minus h, and here will be this h cos h minus h square minus h 1 minus h, which is limit h tends to 0 sin h minus h upon h cos h minus h, which is 0 upon 0 form. So what we'll do is we'll use series expansion here. So it will be this limit h tends to 0 positive. Now sin h is h minus h cube upon factorial 3 minus h, and here if we take this h common, cos h is 1 minus h square upon factorial 2 minus h. Now here h and h will cancel, here also h and h will cancel. So minimum power in the numerator is h cube and minimum power in the denominator is also h cube. So answer to this limit is factorial 2 upon factorial 3, which is simply 1 by 3. So in this case, left hand limit is 1 and right hand limit is 1 by 3. So this limit, it does not exist. Now the question is, we need to find this limit x tends to 0 x plus log under root of 1 plus x square minus x whole divided by x cube. Now for this question, what we'll do is we'll take this under root of 1 plus x square minus x as sum y. Now if we take this x on the right hand side and square it, we'll get 1 plus x square, and it will be y square plus x square plus 2xy. Now here x square will cancel. We can write x as 1 minus y square upon 2y. Now clearly, when x tends to 0, y tends to 1. So we can write this limit as limit y tends to 1, and here it will be x, which is 1 minus y square upon 2y plus log y upon x cube, which is 1 minus y square upon 2y whole cube. Now we can write this as limit y tends to 1, and this is 1 minus y square plus 2y log y, and here it will be 1 minus y square whole cube into 2y whole square. Now we can write 1 minus y square is 1 plus y and 1 minus y. So we write this as limit y tends to 1, 1 minus y square plus 2y log y upon 1 minus y cube and 1 plus y cube, and here will be this 2y square. Now we don't have a problem with this because here it is 2, which is 4, and here it is 2 cube. So it will be 1 by 2, and this is 0 upon 0 form. So we can write this as limit y tends to 1, 1 by 2 into 1 minus y square plus 2y log y upon 1 minus y whole cube. Now for this, what we'll do is we'll let 1 minus y as h. So it will be this limit h tends to 0, and this is 1 minus h whole square plus 2 1 minus h into log 1 minus h upon h cube. Now this is limit h tends to 0. Now here 1 and 1 will cancel, so we'll get this as 2h minus h square plus 2 into 1 minus h, and we'll use expansion for log 1 minus h. So it will be this minus h square upon 2 minus h cube upon 3 upon h cube. Now if we simplify this, we can write this as limit h tends to 0 will be 2h minus h square, and there will be minus 2h plus 2h square, and then minus h square plus h cube, and then minus 2 by 3 h cube plus higher powers of h divided by h cube. Now 2h will cancel, h square will also cancel. Now minimum power in the numerator and minimum power in the denominator is both 3, and we also have this 1 by 2 which I forgot, so it should be this 1 by 2, 1 by 2 and 1 by 2. So answer to this limit will be 1 by 2 and then coefficient of h cube in the numerator, which is 1 by 3, and the denominator it is 1. So answer to this limit is 1 by 6. Now the question is, find a polynomial of least degree such that limit x tends to 0, 1 plus x square plus fx upon x square to the power 1 by x, it must be equal to e square. Now first we look at its form. It will be 1 plus 0 plus f0 upon 0 to the power infinite. Now it will be indeterminate form if it is 1 to the power infinite, and in that case we should have f0 as 0. And also minimum power of fx in this case should be x square, otherwise it will be this infinite form. Now if it is 1 to the power infinite form, we'll use the shortcut directly, so it will be this e to the power limit x tends to 0, 1 by x, and then x square plus fx upon x square. So it will be this e to the power limit x tends to 0, x square plus fx upon x cube. Now this should be equal to e square. Now this is x tends to 0, and in the denominator minimum power is 3. So in the numerator also, this x square plus fx, it should have minimum power 3 to have this non-zero finite answer. That means this x square plus fx, it must be of the form 2x cube to get this limit as e square. And since we are trying to find polynomial of least degree, we have discarded terms containing x to the power 4, x to the power 5. So we'll have least degree only 3. So in this case, this function fx will be minus x square plus 2x cube. Now the question is, we need to evaluate this limit. Limit x tends to 0, limit n tends to infinite, 10x square plus x plus 1 to the power n sin x upon x square plus x plus 1 to the power n. Now if we look at left limit at 0, so it will be this limit x tends to 0 negative, limit n tends to infinite, 10x square plus x plus 1 to the power n sin x upon x square plus x plus 1 to the power n. Now if x tends to 0 negative, then x plus 1 will lie between 0 and 1, and if 1 plus x lies between 0 and 1, then 1 plus x to the power n, it tends to 0 as n tends to infinite. So in this case, it will be this limit x tends to 0 negative, 10x square upon x square which is 1. So in this case, left hand limit is 1. Now, if we look at this right hand limit, it will be this limit x tends to 0 positive. In that case, it will be this limit n tends to infinite 10x square plus x plus 1 to the power n sin x upon x square plus x plus 1 to the power n. Now here in this case, x plus 1 will be greater than 1. That means x plus 1 to the power n will approach infinite. So we'll divide everything with x plus 1 to the power n. Then this limit will be limit x tends to 0 positive sin x upon 1. Now sin 0 is 0. So here left hand limit is 1 and right limit is 0. So this limit, it does not exist. Now here the question is, we need to find this limit n tends to infinite r cube minus 8 upon r cube plus 8. So we write this as limit n tends to infinite, this product r varies from 3 to n, and this is r minus 2 r square plus 2r plus 4 upon r plus 2 r square minus 2r and plus 4. Now we'll separate it in two products. So it will be this limit n tends to infinite r minus 2 upon r plus 2, this product where r varies from 3 to n, and then this limit n tends to infinite r square plus 2r plus 4 upon r square minus 2r plus 4. Now if we look at this, this is a difference of 4, and for this one we can write this as r plus 1 whole square plus 3 and r minus 1 whole square plus 3. So here it's a difference of 2. So terms will cancel after 4 and here terms will cancel after 2. So we can write this as this limit n tends to infinite. Now if we put r as 3, it will be 1 by 5. Now this is 2 by 6, 3 by 7, 4 by 8, 5 by 9, and it will go all the way up to n minus 2. Here terms will cancel after 4. So here we'll have 4 terms. So it will be this n plus 2, n plus 1, n and n minus 1. So we'll have these 4 terms. Now into, and for this one, if we put r as 3, it will be 4 square plus 3 upon 2 square plus 3, and then it will be 5 square plus 3 upon 3 square plus 3, and now it will be 6 square plus 3 upon 4 square plus 3. So these terms, they will start getting cancelled now. So in the end, we'll have n square plus 3 and n plus 1 whole square plus 3, and all those terms, they'll cancel. So we'll get this as limit n tends to infinite. Now this is 24 upon, this is n square minus 1, n plus 2, and here it is n square plus 3 and n square plus 2n plus 4. And we also have 4 and 3 7, and this is 9 plus 3 12. Now here coefficient of n to the power 4 is 24, and here coefficient of n to the power 4 is 24. So this value will be 2 by 7. So answer to this limit is simply 2 by 7. Now here the question is, we need to find this limit x tends to 0, 1 plus, and here it should be fractional part of x. So this is limit x tends to 0, 1 plus fractional part of x to the power 1 upon fractional part x upon e to the power 1 upon fractional part of x. Now, if we find its left-hand limit will be limit h tends to 0 positive. We'll take x as 0 minus h. So it will be this 1 plus 1 minus h to the power 1 upon 1 minus h upon e to the power 1 upon 1 minus h, which is 2 upon e. In this case, left-hand limit is pretty simple and it is 2 by e. Now we'll find its right-hand limit. Now its right-hand limit will be, if we take x as 0 plus h, and we know that fractional part of h is simply h. So RHL will be limit h tends to 0 positive will be 1 plus h to the power 1 by h upon e to the power 1 by h. Now 1 plus h to the power 1 by h, it is e, and e upon e is 1. So this is 1 to the power infinite form, and for 1 to the power infinite form we'll use our shortcut. So it will be this e to the power limit h tends to 0 positive, it will be 1 by h, and then we'll have 1 plus h to the power 1 by h upon e minus 1. So it will be this e to the power limit h tends to 0 eh, and now we'll use the expansion of 1 plus h to the power 1 by h. Now this is e minus eh by 2 and then minus e. Now here e and e will cancel, so this value will be e to the power minus 1 by 2. So left hand limit is 2 upon e and right hand limit is e to the power minus 1 by 2. So this limit, it does not exist. Now here the question is, we need to find this limit x tends to 0. 1 plus x to the power 2 upon x upon e square to the power 4 upon sin x. Now this is 1 to the power infinite form. So again we'll use the shortcut. So it will be e to the power limit x tends to 0, and this is 4 upon sin x, and it will be 1 plus x to the power 2 upon x upon e square minus 1. So it will be this e to the power limit x tends to 0, 4 upon sin x, and here it is 1 plus x to the power 2 upon x minus e square upon e square. Now what we'll do is, we'll multiply and divide it with x. Now x upon sin x is 1, so we'll write this as e to the power limit x tends to 0, and this is 4, and we'll write this as 1 plus x to the power 1 by x whole square minus e square upon e square x. Now this is e to the power limit x tends to 0, and this is 4. Now we'll use the expansion of 1 plus x to the power 1 by x. So this is e, and then it will be 1 minus x by 2 whole square minus e square upon e square x. Now e square and e square will cancel. So we'll get this as e to the power limit x tends to 0. It will be this 4 into, and then it will be this 1 square and minus 2ab. So there will be minus x plus higher powers of x minus 1 divided by x. Now this 1 and 1 will cancel. X and x will also cancel. So value of this limit will be e to the power minus 4. And that's your option B. Now here the question is, we are given this function f and x, which is 10x by 2 into 1 plus secant x into 1 plus secant 2x up to 1 plus secant 2 to the power nx.
Now what we'll do is we'll write this 1 plus secant x as 1 plus cos x upon cos x, and everything else will remain the same. So it is 1 plus secant 2x up to 1 plus secant to the power nx. Now we'll change it in terms of sine and cos. So it will be sine x by 2 upon cos x by 2, and 1 plus cos x will be 2 cos square x by 2 upon cos x, and this is 1 plus secant 2x up to 1 plus secant 2 to the power nx. Now here cos x by 2 will cancel. Now 2 sin x by 2 cos x by 2 is sin x. So we'll get this as 10x into 1 plus secant 2x 1 plus secant 4x up to 1 plus secant 2 to the power nx. Now here it was x by 2 and x, and here it is x and 2x. So situation is same. It is going to be 10 2x and then 1 plus secant 4x 1 plus secant 2 to the power nx. Again situation is same, so it will be 10 2 square x, and will continue till the end where it is going to be 10 2n x. So this fnx is 10 2 to the power n into x. Now we need to find this limit. X tends to 0, fnx upon 2x. So it will be this limit x tends to 0. Now fnx is 10 to the power nx, and here it is 2x. Now what we'll do is we'll multiply and divide it with 2 to the power of n minus 1. Now this becomes standard limit, which is 1. So answer to this limit is 2 to the power of n minus 1, and that's your option C. Now here the question is, we need to find the value of this limit x tends to pi by 4 1 plus greatest integer function of x to the power 1 upon log 10x. Now in this case we must know that when x approaches pi by 4, greatest function of x, it is 0. Now this greatest integer function, it takes exact value. It cannot take limiting value. So this form, it is not of the form 1 to the power infinite. So this limit is just going to be 1, and that's your option B. Now here the question is, we need to find the value of this limit, which is y, and limit n tends to infinite factorial n upon n to the power n to the power 3n cube plus 4 upon 4 n to the power 4 minus 1. Now what we'll do is we'll write this as limit n tends to infinite, and we'll write it in terms of this product that r varies from 0 to n minus 1 n minus r upon n whole to the power, and here also we'll multiply and divide it with n. So it will be 3n to the power 4 plus 4n upon 4n to the power 4 minus 1 into 1 by n. Now what we'll do is we'll take log both sides. So we'll write log y, and it will be equal to limit n tends to infinite 3n to the power 4 plus 4n upon 4n to the power 4 minus 1, and then into this 1 by n summation 1 minus r by n, where r varies from 0 to n minus 1. So we have this form. Now this is infinite limit. Highest power is n to the power 4. So this limit is going to be 3 by 4. So we can write this as log y equals 3 by 4, and then into this limit n tends to infinite 1 by n, this summation r varies from 0 to n minus 1 1 minus r by n. Now here we'll take x as r by n, and this is nothing but this is limit of sum. N tends to infinite, we have 1 by n, and then we have this variable r by n. So it will be this log y equals 3 by 4, and we'll change it in integral form. Here will be this log 1 minus x dx, and then this limit from 0 to 1, which is also same as 3 by 4 0 to a minus x. So we can write this as log x dx. Now it will be this log y 3 by 4, and this is x log x minus x from 0 to 1. Now this is 3 by 4. Now log 1 is 0 minus this limit x tends to 0, x log x, and then minus 1. Now this is 0 into infinite limit, so we can write this as limit x tends to 0 log x upon 1 by x, which is 1 by x upon 1 by x squared. So this limit is 0. So from here we can write log y equals minus 3 by 4, or value of y is e to the power minus 3 by 4. So value of this limit is e to the power minus 3 by 4. And that's your option A. Now here the question is, we are given this function fx, which is this limit n tends to infinite, and this is x into 3 by 2 plus gradient function of cos x, and this other factor in terms of n, we'll rationalize it. We'll write this as n square plus 1 minus n square plus 3n minus 1 divided by under root of n square plus 1 plus under root of n square minus 3n plus 1. Now here n square will cancel, plus 1 will also cancel. So we can write this fx as limit n tends to infinite, and this is x into 3 by 2 plus greatest in a function of cos x into, now since this is n tends to infinite, highest power of n in the numerator is 1 and the denominator it is also 1, so this is 3 by 2. So we can write this function fx as 3 by 2 x into 1 plus greatest integral function of cos x. Now first we will find limit x tends to 0 fx. Now for this limit x tends to 0 fx will be this limit x tends to 0 3 by 2x and 1 plus greatest integral function of cos x. When x tends to 0, this cos x tends to 1, but it is less than 1. So this value will be 0 and x equal to 0 is 0. So this limit will be 0. That means this option A, it is correct. Now if we take this limit x tends to pi by 2, then in that case we have to take two separate limits, left hand limit and right hand limit. So this b, which is limit x tends to pi by 2 negative, it will be 3 by 2x into 1 plus get a function of cos x. Now this is 3 by 2 into pi by 2, and this is 1 plus, and when x is less than pi by 2, cos x is greater than 0 but less than 1. So this greater function will be 0. So this value will be 3 pi by 4, and limit x tends to pi by 2 positive. So when x is greater than pi by 2, this value will be negative. Then in that case it will be 3 by 2 into pi by 2 and then 1 minus 1, which is 0. That means this limit x tends to pi by 2 fx, it does not exist. So this option B, it is incorrect. Now C is fx equals 3 by 2 when x lies between 0 and pi by 2. So if x lies between 0 and pi by 2, then in that case we can write this fx as 3 by 2 x into 1 plus, we get a function of cos x. Now at x equal to 0, fx is 0, which we can also write as 3x by 2, and when x lies between 0 to pi by 2, greatest integral function of cos x, it will lie between 0 and 1, so it will be 0. So in this interval, this fx is nothing but it will be simply 3x by 2. That means this option C is also correct. Now option D is if x lies between pi by 2 and 3 pi by 2. Now option D is when x lies between pi by 2 and 3 pi by 2. Now between pi by 2 and 3 pi by 2, greatest integral function of cos x, it will be minus 1. So this function fx will be 3x by 2 and then 1 plus, and greater function of cos x is minus 1, so it will be 0. That means this option D is also correct. So the correct options are A, C and D. Now the question is, if alpha beta lies between minus pi by 2 and 0 such that sin alpha plus sin beta plus sin alpha upon sin beta, it is 0, and then sin alpha plus sin beta into sin alpha into sin beta, this is minus 1. Now we need to find this limit 1 plus 2 sin alpha to the power 2n upon 2 sin beta to the power 2n. Now suppose sin alpha plus sin beta is A and sin alpha upon sin beta is B, then A plus B is 0 and A into B is minus 1. Now A equals minus B, so we can write A square equals 1, or the value of A is plus or minus 1. Now since both these angles, they are in fourth quadrant, it cannot be positive, so that means sin alpha plus sin beta, it should be minus 1, and if A is minus 1, then B is plus 1. In that case, sin alpha upon sin beta, it should be plus 1. So from here we'll get this condition that sin alpha equals sin beta is equal to minus 1 by 2. Alpha and beta, they're equal and they're equal to minus pi by 6. So alpha is minus pi by 6. Now we need to find the value of lambda. Now if we look at 2 sin alpha is minus 1. And the same way 2 sin beta is also minus 1. So this lambda will be 1 plus 1 upon 1, that is 2. So value of lambda is 2. So the correct options are A and B. Now here the question is, we need to find the value of this limit. Limit n tends to infinite cos square pi, and this is n cube plus n square plus 2n to the power 1 by 3. Now we'll take n cube common, so it will be this limit n tends to infinite cos square n pi, and here it will be 1 plus 1 by n plus 2 by n square to the power 1 by 3. Now what we'll do is, we'll use binomial expansion. So we'll write this as limit n tends to infinite cos square n pi, and here it will be 1 plus 1 by 3n plus 2 by 3n square plus higher power of 1 by n. Now we'll write this as limit n tends to infinite. Now this is cos square and n pi plus pi by 3 plus 2 pi by 3n. Now cos n pi plus theta is minus 1 to the power n cos theta. So it will be this limit n tends to infinite minus 1 square to the power n and then cos square pi by 3 plus 2 pi by 3n. Now minus 1 square is plus 1, and if we take n tends to infinite, all these terms will be 0. So this answer will be simply cos square pi by 3, and cos square pi by 3 is 1 by 4. And that's your option C.